we need to find the relative maximum and minimum values of f of xy equals x squared plus xy plus y squared minus 3x. So we can find out the coordinates of the critical point and then find out the nature, whether it's positive or it's a minimum or maximum point, right? And we can also find out where the maximum point is or the minimum point is. Now we have a copy of the d-test which we will use. So we're going to have to find fx, fy, fxx, fyy, and fxy. Alright? As for the fx, we equate it to 0, fy we equate it to 0, and solve them to find the location of the critical point. Then we evaluate d from d equal fxx of AB, the coordinates of the critical point, times fyy of AB minus fxy of AB, and then that squared. So here now, we find fx, oh no, not f of x, fx is equal to, we differentiate this function with respect to x. So I have 2x plus y minus 3. And fy differentiated with respect to y. Remember, when we differentiate it with respect to x, we treat y as a constant. So when we differentiate it with respect to y, we treat x as a constant. This would amount to 0. xy would be x, the number times y, differentiate with respect to y, we get x, plus 2y, and this will become 0. Alright? Now we want fxx as well. So differentiate this with respect to x. This will be 2. And then fyy, if we differentiate this with respect to y, we also get 2. What about fxy? We differentiate fx with respect to y, that is this with respect to y, we're going to get 1. Of course, if we find fyx by differentiating this with respect to x, we also get 1. Alright? Okay. Now, to find the locations of the critical point, we have 2x plus y minus 3 equated to 0. Remember, you have to equate fx to 0 and fy to 0. And then it says here, let AB represent a solution, alright? AB. These are a pair of simultaneous equations, and we're going to solve them to find the solution. X plus 2y equals 0. What we can do here, we can just use substitution. If we transpose this equation to make x a subject, we have x is equal to negative 2y. Then wherever x is in the other equation, we put this there, right there. So 2 times negative 2y plus y minus 3 equals 0. See that? 2 times negative 2 is negative 4. So negative 4y plus y minus 3 is 0. Negative 4y plus y is negative 3y. Negative 3y minus 3 is equal to 0. Now that means negative 3y is equal to 3. So y is 3 over negative 3, which is negative 1. So y is negative 1. Now when y is negative 1, we could substitute it here, where we have x is equal to negative 2y. Y is negative 1, so we put negative 1 here. So x is negative 2 by negative 1, which is 2. So the coordinates of the stationary, the critical point is x equal 2, y is negative 1. Alright? 2, negative 1. Now we want to find the nature of the critical point. Remember now, evaluate D. D is f of xx, AB. Remember, is f of, let me write this first. D is equal to f of xx of AB times f of yy of AB minus, and then of course it's going to be f of xy by AB squared. So it's f of xy AB, and that will be squared. So D is equal to fxx. Fxx was 2. So we have 2. We don't have any space to put the AB. The AB, let me change it from now. The A would have been 2. So wherever we say A, we'd have put 2. So the 2, 2, 2, comma. And the second value, B, will be negative 1. Alright? So B would be negative 1. You see that? Now, here, we're going to put these values there. So in this case, D is just 2 times, what was fyy? Fyy is 2 as well. If it had said fxx was xy, we would have put 2 times negative 1, because x would be 2, y is negative 1. Or if it had said fxx was 3x y squared, it would have been 3 by 2 times negative 1 squared, because we would substitute the 2 for x and the negative 1 for y. But we don't have any values there to substitute, so we just use the 2 and the 2 minus the f of xy squared now. fxy squared, not f of xy squared. fxy squared. But the thing is, fxy is equal to 1. Right? So what we have is 1 squared. So what is D? D is equal to 2 2 is 4 minus 1 squared, which is 3. D is 3. So you see that? What we want to do now is take a look at the test table and see what happens. If D is greater than 0, that means it's positive, right? D is positive. If fxx is less than 0, then we have a maximum point. Where is fxx again? fxx, here, it was 2. It is not less than 0, it's greater than 0. So D is greater than 0 and fxx is greater than 0. So what we have is a minimum point. So since D is positive, it's greater than 0, and fxx is also greater than 0, then what we have is a minimum point. That's what we have. And we can find out where the minimum point is. We know that it is located at 2, -1. So if we substitute here, the minimum point is located at, when you have 2, -1, x is 2, f of 2, -1, x is 2, y is -1, so you have 2 squared plus 2 times -1 plus -1 squared minus 3 times 2, which is 4 minus 2 once 2 plus 1 minus 6. 4 minus 2 is 2, 4 and 1 is 3, 3 minus 6, equal to -6. So, here. So, 3 minus 6 is -3. So the minimum point is located at -3. Alright, so there we have it. We found out the coordinates of the critical point. We did the d-test to find out that it is a minimum point, and we found where that minimum point is located.